All right, everyone, here we are. We're going to go ahead and work on problem 1 from our Unit 3B review. I want to make sure that you notice up here I highlighted something important in those directions that you're going to make sure you read very carefully. We're supposed to leave our answers in simplified radical form. As a reminder, let's do a little bit of work over here of what that really means. If you were left with, say, an answer of the square root of 20, and you're feeling pretty good about it, but you think, hey, 20 might be able to simplify. Remember, one way to do this is break down a little factor tree. You could even think of 10 and 2 perhaps, and then that 10 is going to break down to 5 times 2. And so what that really means is that the square root of 20 is equal to the same thing as the square root of those factors, 5 times 2 times 2. Now, if you experience a pair of the same factors, that means that one of those can be brought out and that the pair ends up going away. And so we're actually left with a more simplified answer of 2 square root of 5. So we want to make sure that we leave any of our responses that have these in that sort of form. Now, on to the problem. We're supposed to graph the points A at 1, 1, so that's over 1, up 1. We're going to label that A. And then over to 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. We're going to go ahead and call that B. It says to draw the segment between them. Okay, let's do this. So there we go. We've got a segment between A and B. Now, on to problem A. It asks us to draw the slope triangle and find the slope. I'm going to go ahead and set myself up here. I know that slope is typically represented by M. And so onto my triangle. The slope triangle is kind of like the up and over from one point to the next. So I'm going to start at A, and I'm drawing up until I get to where I know B will be once I take a hard right. So here I go over to B. How you doing, B? And so now I take a look at those movements. I went up 5, and then I went over 4, both of which in the positive direction. So that means that my slope, which is the up and over amount of 5, divided by the left to right amount of 4, once again, both in the positive direction. Now, on to B. Find the area of that slope triangle. I'm just going to go ahead and draw in a little right angle symbol here because I think that might help us later on. So find the area. Area of a triangle, as we all know, is equal to base times height divided by 2. Or, I know that some of you guys like to think of it as 1/2 base times height. It's all the same stuff, so feel free to use whichever you like. Now, our height and base in this case are the 5 and the 4, since they connect at that 90-degree angle. And so I'm going to go ahead and write that the area is equal to 5 times 4 divided by 2. This simplifies nicely to 5 times 4 makes 20 divided by 2. Feeling pretty good about this one, which breaks down to 10. And since it's an area question, even though there aren't units provided, I'm going to go ahead and list units squared, since area always has that exponent of 2 right here to indicate square units. Now, problem C. I'm supposed to find AB. Now this doesn't mean, hey, look over there, I found it. It's right there. It means something different. It means find the distance, find the length. How large is segment AB? You could always use the distance formula, which as a reminder is the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. Let me just extend that. So that's always in your tool belt of options. However, the way that this one is set up, we could simply use the Pythagorean theorem since this is a right triangle, and we're going to go ahead and solve for AB. So let's take that approach. We know that the Pythagorean theorem tells us that a squared plus b squared is always equal to c squared, c being the hypotenuse in this case. Now, what I'm going to do is I just want to highlight that segment that we're trying to find. So we're trying to find the distance of segment AB. Let me get back to my pen here. There you are. And little Orange Nation pride. Okay, so c squared, or the c value, is always opposite that box. That 90-degree box is pointing over to that hypotenuse. So I know that I'm actually trying to solve for that c value. So I'm going to go ahead and plug in 5 squared plus 4 squared equal to c squared. 5 squared simply means 5 times 5, so that's 25 plus 4 squared means 4 times 4, not 4 times 2. And so this comes out to 16 is equal to that c value squared. Now 25 plus 16 adds together nicely to make 41, equal to a certain quantity called c squared. And at this stage we need to undo that squaring. So to undo the squared, you do the square root operation, And this is going to lead us to a c value that is equal to the square root of 41. Now, I'm going to pause for a second and kind of look back up there. I know that I have a square root involved. I have 41, but I just cannot think of multipliers that make 41. So I'm going to go ahead and leave it as simplified right now. Now, on to our last question, on to D. So D is asking, hey, what is the perimeter of this triangle? Remind yourself that perimeter simply means the addition of all sides. So I'm going to come on over here. I'm actually going to go back to the picture and just write in the square root of 41 next to segment AB. So let me scroll up a moment. And now that I see the full triangle, I can see the lengths of all sides. So I know that for perimeter, I'm going to simply say that the perimeter is equal to 5 plus 4 plus the square root of 41. Now 5 plus 4 can add nicely to 9 plus square root of 41. And since these can't add together, since they don't have the same radical amount, I'm going to go ahead and just put a nice box around that and consider this baby done. All right, thanks for watching.